Alright, welcome to Simple Probability and Odds. You will want these definitions up front here. The probability of an event is the ratio, as we know, it's a fraction of the number of favorable outcomes for an event to the total number of possible outcomes. So for instance, when you roll a die, there are 6 possible outcomes, 1, 2, 3, 4, 5, or 6. And that list of possible outcomes is called the sample space. So you want those two definitions, and we'll go through some examples and see what that looks like um, with probability and finding sample space and things like that. All right, so if we're looking at a die, what is the probability of rolling a 1 or a 4? Okay, well, let's look at our sample space first. Remember, we have 6 possible outcomes, 1, 2, 3, 4, 5, or 6. So the total possible outcomes is going to go on the bottom. And then we're going to look at our favorable outcomes. Well, a favorable outcome will be a 1 or a 4. So that's 2 out of 6. And then with probability, you're always going to want to reduce that. So 2 to 6 we can reduce to 1/3. So 1/3 would be our probability there. And some people do convert that into a percent. You can do that. So 33 1/3%. Look at it that way too if you want. All right. This particular example, the second one, I'm showing you how to write in probability form. Sometimes you'll see just this right here. This means probability of rolling an even number, or what is the probability of getting an even number if we were going to roll one. So let's take these same numbers here. And how many evens are there on this die? We've got 1, 2, 3, and we have 6 possibilities, so 3 out of 6. 1/2 or a 50% chance of rolling. So that's how probability works. And it can get a little more complex. For instance, with this example, we have a bowl that has 5 red chips, 7 blue chips, 6 yellow chips, and 10 green chips. 1 chip is randomly drawn. Find each probability. So letter A, what is the probability of rolling a blue? Okay. Well, we have to look at our sample space first. The total possible outcomes, or how many total chips are there in the first place? So we got 5, 7, 6, 10. So we're going to want to add those up. Okay. So 5 and 7, that's going to be 12, plus 6 is going to be 18. So we've got 28 possible outcomes. Okay. And we want to look for the favorable outcome. Well, the favorable outcome here is blue. So the chances of getting a blue, well, we've got 7 blue chips. So 7 out of 28. And that can be reduced if we divide both of these by 7. We get a 1/4 chance that we will get a blue chip. All right, letter B, the probability of getting a red or yellow chip. All right, so still the same amount in there. So we're still out of 28 here, but now we're going to look at, okay, if I get red or yellow. So I'm going to look at, oh, I erased my highlighter. All right, so red or yellow, we're going to look then for, there are 5 red and there are 6 yellow. That's going to be 5 plus 6, which is 11. So 11 out of 28. Can't reduce that, but we could turn it into a percent if we wanted to. We could do 11 divided by 28 and see what that comes out to, or we can leave it just like that. All right, and then letter C, the probability of not getting green. You can do this one of 2 ways. we can figure out what the probability of getting green would be, and then subtract that from 1, because 1 is 100%, or 1 out of 1, you know, would be, or it'd be like saying 28 out of 28 possibilities, that's 1. Or we could count up all the ones that are not green. So for instance, I could count up 5, 7, and 6, and do it that way. So 5 plus 7 plus 6, so it's going to be 12 plus 6, which is 18, and put that over 28. That's an option. Or I could have taken 28 minus 10 to get 18 and gotten this, and we can reduce this as well. Divide each by 2. 9/14. That's one option. So there we go. The other way we could have done that, like I said, is, well, what's 28 out of 28? That's all possibilities considered, but we're going to throw out the chance of getting green. So the probability of not getting green would still give us this, which would reduce by this. So that's another option. Lots of different methods you can use there. All right, so that's probability. Sometimes a tree diagram may be helpful, especially when you're looking for the sample space. So here's an example of this. What is the probability of flipping 3 heads and 3 flips with a penny? All right, so this just helps organize things. So if you've got a penny that you're going to flip 3 times, what's going to happen on the first flip? Well, you can either get heads or tails. All right, now let's go with the first track. Let's assume you get heads on the first flip. What can happen on the second flip? Well, again, you're either going to get heads or tails. All right, let's assume again we get heads. You're still going to get heads or tails on your third flip. And we start to get this tree formation. All right, let's say you get that. Or maybe you get heads, and then you get tails. Okay, or maybe you get heads and then you get tails, and then what? Well, no matter what, you get heads or tails again. So you can kind of see this. They call it a tree. If I was drawing it vertically, it would look more like a tree. So you're kind of laying out all your scenarios here. So then, for instance, let's say on your first flip you get tails, and then on your second flip you get heads. And then maybe on that third flip, then you get heads again. Or maybe you get tails instead. So it could be tails, heads, tails. Tails, tails, heads. Or tails, tails, tails. Alright, so here's how we can kind of look at this. How many different possibilities are there? Well, we just count up the last column. So 1, 2, 3, 4, 5, 6, 7, and 8. So there are 8 possibilities. Alright, so that's our sample space there. And then all we got to do is look at, okay, here's how you can read this. So for instance, we're looking for flipping 3 heads. Well, there's 1 heads, there's the next one, there's the next one. Okay, so you need to look at the path that gives you all heads. Are there any other paths that give us all heads? Doesn't look like it. For instance, if I look at this one, this would be heads, tails, heads. Alright, so it just goes through and shows you all of those. If I look at the bottom one, that would be like saying tails, 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 if I follow that path. So it's all about following the path that you're looking for. So heads, 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 there's only one option out of the 8. So the probability of that happening is 1 in 8. Alright? So that's how you look at that. And that's how you read it. So is that the only way you can do that? No, you wouldn't have to do it that way. You could go ahead and try to figure this out on your own and say, okay, well, here are my options. I could get heads, heads, heads. I could get tails, tails, tails. Heads, heads, tails. Tails, tails, heads. And then go through and figure out all the possible outcomes. You could do that with a table or just by organizing it yourself. And you should still come up with 1 in 8, a 1 in 8 chance of flipping 3 heads and 3 flips. So that is one way to go about that, or another way. I'm sorry. fundamental counting principle is basically just saying, if you have so many different options, for instance, with an outfit, so let's look at this example. How many different outfits can there be if a man has 3 pairs of pants, 5 ties, and 4 dress shirts? You could go through and make this very complex if you wanted to. And you can do a tree diagram if you want, but if he has 3 pairs of pants that and 5 ties and 4 dress shirts, the fundamental counting principle says I can just multiply all of these together, and I've got 60 different outfits that I can get from that. Okay. Don't believe me? Go ahead and make a tree diagram and prove it. But that's what the fundamental counting principle says. With all the different options, you can just multiply them all together, and you should be able to get all the different outputs. Help you get that sample space. All right, last thing I need to talk to you about is odds. Odds are different than probability. You want this definition. So the odds, that's a ratio of the number of successes versus the number of failures. So the number of odds of rolling a number less than 3 . Okay, and I'm just going to show you the difference here. So a number less than 3 would be 1 and 2. That's 2 out of 6, right? That would be the probability. So the probability equals 2 out of 6. So that's not what they're asking us for. They're asking us for the odds. The ratio of the number of successes. So here are my successes. There are 2 of them. And here are my failures in this instance. So these are all failures. So we would say there is a 2 to 4. There's the odds are 2 to 4 on this, and we can always reduce this then. Divide both of these by 2. It's a 1 to 2 odds that you will get a successful shot on that. So that's the difference between odds. So the probability of this one actually is 1/3. But the odds, 1 to 2. All right, so that's the difference. All right, that should be all I have. So we will see you in class.